So this is a system of equations, and we know it's a system because we have two equations with the same unknowns, two equations with the same variables, x and y. And you may see a system written also this way with a set on the left-hand side. It means the same thing. We have a system of equations. We're interested in finding the intersection. In this case, we have two lines, so we're looking for the intersection of two lines. So this is going to be a system that is set up nicely for substitution, and that's because y is already isolated. It's by itself in one of the equations. So we're simply going to take x plus 2, and we're going to substitute that into the top equation in place of y. So we will have 4x plus, and instead of y, we're going to substitute in the x plus 2, and that's equal to 4. And then just simplify and solve for x. And we'll have that x is equal to 2/5, 2 over 5. Now remember, because both of these equations have x and y raised to the first power, we could rewrite each of these equations in slope-intercept form. These are two linear equations. So remember, if they're linear equations and they're two lines, and we're interested in the intersection of these two lines. And right now it appears that we have the x value of the intersection. So we're going to write our solution as an ordered pair. It's the point where these two lines intersect. Therefore, we need to not only figure out the x value, but we also need to figure out the y value of this point of intersection. So we're simply going to take this x value and then substitute it back into one of the top two original equations. And it's probably easiest in this case to go ahead and substitute it into the bottom equation since we're interested in finding the value of y. So y is equal to x plus 2, that was our second equation. So therefore y is equal to 2/5 if I substitute my x value in place of x. So that's 2/5 plus 2. And then just get a common denominator. That would be 2/5 plus 10/5. So it looks like my y value is 12/5. Therefore, the intersection of these two lines is at 2/5, 12/5. And this would be the solution to the system of equations. Now, just as a reminder, if you were wanting to take this system and check it, we could certainly check it using our graphing calculators. We would want to graph both of the lines. And I encourage you to go through these steps of making sure that you could actually check this graphically using your graphing calculator. You want to graph both of the lines. Well, if you take a look at the top line, 4x plus y equals 4, you would have to go ahead and rewrite that in slope-intercept form, solve for y equals negative 4x plus 4. So that way, this line is ready to be put into your graphing calculator in your y1. Then the bottom equation, which was y equals x plus 2, nothing needs to be done for that equation since y is already by itself. So you'll put that into your y2. Then you'll go ahead and graph both of these lines. And then remember, you have a button at the top of your calculator that says trace. And above the trace button is your calculate menu. So you want to go ahead and go second trace, which will bring up that calculate menu or calc menu, and then choose number 5. And number 5 says intersect. And then you can follow the prompts. It'll ask you what's your first curve, press enter, second curve, press enter, then it'll ask you for a guess, press enter again, and it'll give you the intersection, the x and the y values of that point of intersection, and it should be 2/5, 12/5. Of course, it will give it to you in decimal form.